everybody. My name is Charlotte Hauser, as you just heard, and can you hear me? Okay, maybe like this. I'm a professor of bioengineering. I'm similar to Jenny. I'm coming from the material side. So I'm a chemist, material scientist. Yes, great. And similar as her, I believe, or I'm sure material matters. Yeah, okay, like this. Thank you. Sorry. And today I have actually only very short time, but I would like to tell you what we do from the material side in order to hopefully contribute to coral reef restoration. And normally, I cannot show you this one now, but normally we work, my research is in tissue engineering, bioprinting, so I'm coming from the biomedical side, but talking with our marine scientists at KAUST, we got ideas what we could do for reconstruction. So you see here actually 4 different subjects, and I will talk only on the first and second part. Will give you some ideas what we are doing there on the coral hybrid fabrication process and fabrication and of skeleton structures and by printing and by molding. I will not talk about bioadhesives. We have developed certain glues for doing the microfragments gluing on the coral, printed coral structures, and also how to use biopolymers for growth enhancement of corals. So basically, this is a method we call 3D Coral Print, and it was published recently in ACS Sustainable Chemistry and Engineering. And what's all about? There we have 3 major steps to go through. That's replication steps, where harvesting, scanning, and modeling comes in. The fabrication step, where robotic 3D printing comes in, print or molding. I said we developed a hybrid process, and the material synthesis, so we do the material all ourselves. And then the propagation step, where microfragmentation, seeding, and field deployment plays a role. So as of the process in more detail, so there are 2 different methods which we are suggesting, and actually, and you see something which is called here CCP. So this is something which this is a specific material which we developed. I come to that soon. So by starting doing scanning of the structures and re-engineering, when we have the models for the printing ready, so there are 2 ways which we are going for, and actually the first method A is something where we do with just a PLA polymer. We are doing the structure, printing it in cheap polymer structure in this case, in order to create a mold from silicon. And this mold then using our final material, which we actually think or need for the real structures, is the CCP structures, then these structures are by molding constructed or fabricated. The same thing is we could actually create the same structure by printing directly, and you might wonder why going A or B. And so you see here already the method A is a longer method, method B is a shorter one, but method A has some advantage over method B in a certain way, which I will can explain shortly later. So this is the first step where the scanning comes in, and the model, the CAD model, and then the model for the printing. And now to the material. You saw in Jenny's slide that all the materials, cement, ceramics, etc., which are used, metals, concrete, either they are not natural and not really coming close to the real coral skeleton, or are actually a complex composition of minerals, of silicates. Quartz was mentioned, 2 minutes, yes. Thanks. And this one here is just simple, a very simple recipe we found, just taking calcium carbonate by itself. And this photocurable resin looks like complicated stuff. It's from plant-based, it's lipids from plants, basically, with a photoinitiator, which can be LED light in order to get that CCP paste for the printing. It's a very quick and simple way of going. And here you see the steps A and B. Um, and I told you we are preferring at the moment method B of different, because although the process is longer, the molds, you can make masses of molds, and I just can, believe me or not, might not see it, but the printed structure and the molded structures, you see it in the middle, are actually basically the same. But the printer is cheaper, the way is longer, slightly longer in the beginning, but when you have a lot of molds, you are actually speeding up the process. So these are here the fabricated molded structures, as of branch structures, as of so-called brain coral structures. You see these flat areas where we deposit the fragmented seeds, and that's how it looks like when we go into the tanks. And at the end, you see, so in the beginning, it's the seeding process on brain-like structures or branch structures, which are molded or printed. And then after roughly more than 6 months, you see how the tissue is nicely developing. And this is, by the way, a structure which we have over 2.5 years, and the size really doubled over the time. This is still in the tanks. The overall approach is, of course, going to the field. So these are, and you see at the in the upper left side, this is Hauser Coral City, where we deployed our printed and seeded structures over time. And we have now, we are observing and we are looking basically for coral growth. We have, I cannot show you the data now, yet it's ongoing, how we see advantages on our coral CCP skeleton structures over other surfaces. And what's next at the end, just wanted to say, the idea would be, and we are working on that one, having not only these structures printed, these skeletons, but really also interlock holders where we can deposit it, also printed from CCP, and then in a Lego system applied in order to make 3D structures. So that's from my side, and this is the team. And we are, in the moment, collaborating with members from the marine science, and Professor Duarte, Manuel Aranda, Raquel Peixoto, and their colleague Sebastian Schmidt-Roach is here at the conference. And this is my team. We have different expertises, so I'm very grateful to the team, from chemists, from the engineer side, biologists. No marine science at the moment, so we are happy to have marine science joining us at one time, and happy to answer questions if there are questions. Thank you.